I'm Trisha. I am going to talk to you about developer productivity engineering. I'm doing several talks at this conference. This is the one I've given the most times, so I'm most comfortable with the talk, which means that it's the one that's definitely going to go wrong. So be ready to put it on social media and laugh about it later. I'm Trisha G. I'm lead developer advocate at Gradle, Java champion, 20 years experience as a developer. Don't tell anyone that I might have worked for, but one of the reasons why I'm so passionate about developer productivity is that I've worked at a lot of places where the job was not very productive and where things did not go quite the way I would have liked for it to go as a developer. So that's why I spend a lot of time kind of talking about things that make our jobs easier as developers. So I've done a whole bunch of stuff around Java, and I say obviously, but if you remember, I'm usually here at Devox talking about IntelliJ IDEA. This slide is up here so you can buy my books. There is an opportunity to enter a raffle to win one of the books at the end of the talk, so please stay to the end of the talk so that you can win a copy of my book. Right, let's talk about developer productivity. Imagine these kids, real kids, and imagine what they've done is done something like, I don't know, something simple like Hello World. They told the computer to do something, and it did it. And it gives them that sense of, yes, it works. It does what I want it to do. And I would like to think that a lot of us are in this room because we've had that experience as developers when we first started out. Now imagine these kids have got like build times of 20 minutes, 30 minutes, test times of like, I saw one today which was 6 hours. I don't think they would quite get that instant gratification of, it does what I want. They'd be like pressing a button and going, I don't know. I don't know what's happening. And I'm just going to go off and get 57 cups of tea. And what happens to us as professional developers, assuming we have a good day for coding, by good day I mean a day with no meetings, no other crap that gets in the way, a coding day, our day might still look like this, where we spend some time writing code, and then debugging the build, debugging test failures, trying to figure out what went wrong. We go for lunch, we come back, write a bit more code, and then it works. And then we put it into CI, and then we wait for it to go through the CI pipelines. And then we have a test which fails, which doesn't look like one of our tests, so we're not really sure if we broke it, or if it's a flaky test, or if it's a good indicator that we broke something which is unrelated to what we thought. We spend a lot of time going down that rabbit hole, and then maybe we might actually commit something, the thing we started working on 8 years ago. So yes, as I said, this is a good day of code. This survey from 2019 suggests that we spend about 32% of our time writing code. So if we only spend 32% of our time writing code, and on those good days, we spend half of the time troubleshooting build failures and waiting for tests to run and figuring out that this is a flaky test and nothing to do with us, it's really not an effective use of our time. And that's the time that we enjoy. That's the coding time as opposed to the meetings, etc. There's a quote from Dell which says, bottlenecks in the toolchain are holding back the rockstar 10x developers. I hope that anyone who knows me knows I'm somewhat cynical about 10x developers, and particularly the term rockstar. I have worked with developers who are very, very good. I have worked with people who are better than average. But the idea of this 10x engineer, I think, is kind of as mythical as unicorns and El Chupacabra. I feel like this is something which is the industry really wishes to believe that there are these individuals you can find who are 10 times more effective. But I think reality is that that's not necessarily the case. So where did the idea of the 10x engineer come from? There's a book called Peopleware, and when they were creating this book, or in order to lead up to the creation of this book, the authors ran something called the Coding Wars. And what they did is they would pit two developers against each other to compete on the same task, to complete the same task. And then they would kind of figure out which of these developers was the best, which was the most effective. And they'd use that to measure how effective and how productive individual developers were. And what they found was the best programmers, for some definition of best, the fastest, the people who produce the least bugs, they outperformed the worst by roughly a 10-to-1 ratio, which sounds like this idea of the 10x engineer. But if you dig in a little bit deeper to find out what really contributed to the 10x engineers, it's not as simple as that. The programmers who competed against each other performed at roughly the same level. What's interesting about this is they're not collaborating on this thing, they're working against each other, but they come from the same organization. And they're working on this thing in their normal organizational setting, with their normal computer, with the normal amount of meetings, with the normal office space, with the normal amount of interruptions. So it's not necessarily that an individual developer is 10 times more effective than another one. What they actually found is the best organization performs 11 times better than the worst organization. And yet somehow this has all been internalized as it's our fault as engineers. We are 10 times less effective than the 10x engineer, when in actual fact, it's organizations who can enable all of their engineers to be 10 times more effective. And there was another study done around about the same sort of time, and the conclusion there was, while this productivity differential among programmers is understandable, this 10x engineering, it says there's also a 10-to-1 difference in productivity among software organizations. So again, another study finding it's the organizations which enable us to be productive, not necessarily the individual engineers. And if we go back to coding wars, what they found is that those who performed in the first quartile, the most effective, had more space to work, had more quiet, more privacy. They were able to silence their phones more often. They were able to divert their calls, phone calls and diversions. And I can imagine this idea of a desk phone, which I used to have when I started in my career. How novel. And they had fewer interruptions. So those who performed better had a more effective, more productive working environment. It's not necessarily that they're better engineers. The conclusion from the book was, the bald fact is that many companies provide developers with a workplace that is so crowded, noisy, and interruptive as to fill their days with frustration. That alone could explain reduced efficiency, as well as a tendency for good people to migrate elsewhere. Now, I think this last sentence is really interesting, because now what you find is, not only are the least productive organizations impacting their developers' ability to be productive, they're also pushing away the developers who have a choice in where to work. So they're also unable to attract and retain the best development talent. So you have this double whammy of, my developers aren't effective, and also I'm no longer able to attract and retain really good developers. So what has this got to do with developer productivity engineering? So DPE is a software development practice used by leading software development organizations to maximize developer productivity and happiness. So the idea is that at Gradle, we're trying to talk about DPE, but it also falls under the same sort of blanket as platform engineering, developer experience. There's a lot of terms in this kind of area. But the idea is to figure out a way to not only maximize developer productivity, but the happiness of developers, which is much more important to me as a developer than my productivity. This is something me and Holly are going to talk about in our talk tomorrow as well, so it's all related. And what is DPE about? DPE is about the sort of friction and rubbish that gets in the way of our day job. Some of this stuff that slows us down, some of the stuff that the organization can potentially own and make better for us. So things that take too long, long builds, long tests, long deployments, things that take too long to fix because you have limited visibility over the environment you're fixing it in, or because you don't have the tools you need to troubleshoot and debug problems, and things that should never have broken in the first place, stuff that should not be breaking. And if you think about, this is my experience as a developer, there's a lot of small niggly things that get in the way of your job. Things like build times taking too long, whatever too long looks like, or tests that are flaky, tests that get in the way. And I think we've got really used to sort of saying this is part of our job. Our job is just to kind of put up with a lot of these little niggly things. But if you add up all the little niggly things for every individual developer, for every day they code, for every one of your developers, you've got decreased productivity and increased cost across the board. So all these tiny things that get in the way of us as developers is having a massive impact on the organizations we work for. And the idea about DPE is that we've been doing incremental improvements to our processes over time, including, so I worked at Ford, and we did just-in-time manufacturing and business process. We did all of these things at Ford and Lean Six Sigma. And I was working with Dave Farley when we did continuous deliveries, DevOps, and DPE is kind of the next thing to kind of capture some of the stuff we haven't really addressed yet. the idea that we haven't necessarily found all of the bottlenecks which are getting in the way of our development throughput. And a lot of these problems are hiding in plain sight in what's called developer experience. So to come back to our 10x organization, our 10x organization should be reducing build and test feedback times. I mean, we would say this because we work for Gradle. So we want to reduce build and test feedback times and helping developers troubleshoot problems and improving the consistency and reliability of builds. For me as a developer, I found this consistency and reliability thing a tricky thing that we don't always focus on, particularly in our local environments or in some of our staging and QA environments. We don't always have the consistency and reliability that we should be able to expect. So I'm going to talk you through 5 different pain points that DPE specifically can address, and some of the solutions we can be looking at to help address these pain points. The first pain point is waiting for builds and tests to complete. Again, like I said, work for Gradle, so builds and tests, quite important to us. Is anyone here tracking how long it takes to run your local build and test cycle? Okay, that's pretty good. I would say 10, 15% of the audience. But surprisingly, not everyone. And I say surprisingly because if you didn't put observability in production these days, the organization would be like, why don't we have visibility over what's happening in production? And yet we have no visibility over what we're doing and what's stopping us doing our jobs in the day job in our local environments. There's another book called The Goal, and this was the one that kind of popularized the idea of the theory of constraints. And in this he says, the only initiatives that will positively impact performance are ones which will increase throughput while simultaneously decreasing cost. I particularly like this quote because I feel like tech organizations that are firing developers are doing the decreasing cost, but not doing the increasing throughput. If you remove developers, you are decreasing throughput. So if you really want to positively impact the performance of your organization, you need to be doing these 2 things, increasing throughput, which will, and do that whilst decreasing cost. And faster build times can improve creative flow. They can improve this feedback. So this is from real customer data that we had. The first team had 11 developers. They have a build time of 4 minutes, which in my book is not terrible. And so they tend to run around 850 builds a week locally. The second team has 6 developers. They've got half as many developers, but their build time is 1 minute. And they can run 1,000 builds in a week. So that smaller team has higher throughput in terms of getting that regular feedback of what's happening with their builds, just by decreasing their build time from 4 minutes to 1 minute. And that's like, I mean, a 4-minute build time is not terrible, but if we can see the impact we have on reducing that, imagine if you've got a 20-minute build time, what you can get if you can reduce that sort of build time. Oh, yes, I want to ask. Build times. Whose build times, the main project that we work on, say, who has a build time of less than 5 minutes? About half of you? Okay, I don't know whether I should go up or down. Who has a build time of less than 2 minutes? About half of that again. And who has a build time of more than 20 minutes? Okay. I mean, that's kind of normal, you know. You have a whole, and it depends as well. It depends what you run, right? It depends whether you're going to do -d skip tests or not, for example. That is not an acceleration technology, by the way. Right, so very fast feedback is important. Why is very fast feedback important? Well, there's a lot to look at in this slide, which normally means I don't like it, but there's a lot of good things. If you've got faster feedback cycles, you can build more often. That's good because if you build more often, you get earlier quality checks, you get fewer expensive downstream incidents. As we know, the sooner you find a bug, the cheaper it is to fix it. So you get improved quality. If you've got smaller change sets, you have fewer merge conflicts, you have more efficient troubleshooting, and faster MTTR, mean time to recovery. Every time I forget what that means. Faster fixing stuff. So that leads to improved quality and increased productivity. And if we go back here, faster feedback cycles, less idle/wait time, less context switching. I think by now most developers know context switching kills us. We say we're multitasking. We're not multitasking. We're badly doing 2 things at once. So less context switching, more focused developers, which is increased quality and increased productivity. With shorter feedback cycles, there's basically no downside to this. We get improved quality and improved productivity. So it's something we should definitely be focusing on in terms of improving our developer experience. We really want fast feedback. How do you get it? In our case, we're suggesting acceleration technologies. There are 4 specific acceleration technologies I will talk about in the rest of the talk. We have the build cache, predictive test selection, test distribution, and performance continuity, which when you move them all together will help decrease this feedback cycle time. So first up, I want to have a look at the build cache. Build cache is for speeding up builds and tests. The fastest build or test that you can run is one that you don't have to run at all. So if you've cached the results of previously running a build or previously running a set of tests, you don't have to rerun those things because you've already done it once before. So build caching has been in Gradle since 2017. A bunch of large organizations I've seen kind of roll their own build caching, and the idea of a build cache is it can work locally and remotely. And we'll talk about both of those things. But the fundamental concept is, like any cache, if you have the same inputs, you should have the same outputs. If your code hasn't changed, you don't need to rebuild it. If your code, your files, your dependencies for a particular task or goal hasn't changed, you shouldn't have to rerun that task or goal. You just bring the results from cache. Now, if you've been using Gradle, who's a Gradle person? OK, that's a lot of you, actually. Who's a Maven person? OK, that's right. 2, both of those things. Yes, this is normal. And the technology we're talking about at Gradle, surprisingly, we support for both Maven and Gradle. So Gradle loves Maven. I don't have that T-shirt on today. So this is not just about Gradle. If you have the same inputs, you should be able to cache the outputs, whether it's the most recent build, which is what you get for the up-to-date checks, or an older build. I'm going to give a demo. I'm going to do the demo for Maven to prove that it works for Maven as well as for Gradle. So I have a Maven project. Oh, no, I don't. Hold on. I will have a Maven project in a minute. OK. I have a Maven project. It's a multi-module Maven project. It's a real project. It uses, I have Docker in the background. It uses test containers to spin up MongoDB. It runs a bunch of unit tests and integration tests and stuff. And it takes about 4 minutes to run all of these modules. You can see these are the various modules and how long it takes. I didn't want to run that live because you don't want to sit and watch it running for 4 minutes because that's not very interesting. So let's apply the build cache, which in this case, I'm going to use Gradle's Develocity plugin. And when we do this, yes, overwrite that, we will see we have, I'm going to add a new extension, which is the Develocity Maven extension, and some settings for Develocity, which is going to be, I'm going to point it to our learning instance, which is not currently live yet, so don't go and hit it, because it's there, but we haven't launched it yet. And so then that's all we need to do. And then if I run the build again, even if I do a clean, now, I've checked this demo 3 times today, and it absolutely did work, which means that right now it's not going to work. When I did this at DevNexus, it went, no, I'm not going to use the build cache. I just don't really want to. There you go, loaded from build cache. OK? So it's not rerunning every single goal for every single module, because I already ran that build earlier on, so I put it in the build cache. And then the build takes 21 seconds instead of 4 minutes. It's a bit of a cheat, because I didn't make any changes, so obviously it got everything from the build cache. But it's a multi-module project. So if I make changes to one module, I don't want to have to rebuild everything. I only want to rebuild the stuff that I actually changed. So you can get some significant savings from adding the build cache to your project, particularly for multi-module projects. Wow, my demo worked. What is going to go wrong? OK. Where it gets really interesting, in my opinion, is that you can have remote build caches. So your code is regularly built, right? It's regularly built by your CI environment, I hope, right? You are built, thank you, nodding, yes. So when your code is built in the CI environment, it can put the results in the build cache. And now imagine on Monday morning, you get to your computer and you update your code from the most recent changes from your whole team over the weekend or the last week or whatever. You do not need to rebuild all of those changes on your local machine. You get the changes from the remote cache, because CI already built all that stuff. So I don't need to waste time and spend, whether it's 1 minute, 15 minutes, 10 minutes, 3 hours, I don't have to waste that time. I just get the results from the remote cache. And not just me, everyone in my whole team. So I get those savings multiplied across everyone in the organization just by putting the results from CI in the remote build cache. So that was our first technology. Our second acceleration technology is test distribution. This is a way to parallelize test execution. Now, you're thinking, I already run my tests in parallel, I hope. You can run it locally in parallel if you're using Gradle. These are the various options to run it locally. You can even do it with Maven, which I didn't know until I joined Gradle, which is a bit odd. But yes, you can even run them in parallel for Maven too. So you're running things in parallel locally, but that is limited by the number of CPU cores that you have or the amount of resources you have locally. You're going to be running stuff, I hope you're running stuff in parallel in CI. There's various ways to slice and dice it. Either, you just kind of have a whole bunch of agents running the tests separated, or whether you've got integration tests, acceptance tests, or whether you're slicing and dicing it by operating system, or whatever. You're almost definitely using multiple agents to run tests in CI. So that's good too. But it's not necessarily the same kind of parallelism you were getting from your local build. So given the existing solutions of using the build cache, single machine parallelism, and CI fan-out, those things are great, but there's a limitation to that. Like I said, when you're running it locally, you're limited by the number of CPU cores. When you're running it on CI, sometimes it requires like some sort of manual partition of those different tests. What you really want is you really want to give your tests to some sort of test distributor, which will then just fan it out over a whole bunch of different agents. When I worked at LMAX here in London years ago, we rolled our own version of this. So we just took the list of JUnit tests from Jenkins, probably, and then just said, right, we've got all these agents lying around over our various local machines and cloud machines, and we just give out the tests to the various agents which are running. And it works for local builds or CI builds. Gradle's Develocity solution also does this, but it doesn't have to be. I mean, if you want to buy Develocity, that would be great. Our salespeople would be very happy to hear from you. But this is not necessarily a sales pitch. This is a thing that you can do with your tests. And with test distribution, generally speaking, if you double the number of agents, you halve the build time. I mean, that makes sense, right? You've got however many tests running. How many tests is that? Let's say it takes an hour and a half with just one agent. Then with two agents, it takes half that time, and so on and so forth. So this is great. There will also come a point, probably around about here, where you don't need to add more agents because you're going to get diminishing returns from that. So you want to find your optimum amount of agents. And we have a story of Netflix using Develocity's test distribution to reduce their 62-minute test cycle time to under 5 minutes, because they can just run all of their tests massively parallelly. The next step is AI, because we're in 2024, and if you don't mention AI in a conference talk, you're not going to get accepted, and no one's going to talk about you. So we have machine learning algorithms which can also help to improve running tests and builds. A little while back, Meta did some research to figure out, they have this like monolith with huge amounts of tests, and they were trying to figure out, if I only change this amount of code, I shouldn't have to rerun all of my tests everywhere. It just doesn't really make any sense. So they did a bunch of different things to figure out, how do I determine which tests I need to run in order to figure out whether I broke something effectively? So they tried a bunch of stuff like dependency tracing and things. They found with dependency tracing, ultimately, like every single change needs you to run every single test one way or another. So they're like, oh, that can't be right. So they did some machine learning, and what they found is that when you change certain sets of code, only a subset of tests will likely fail, really. That's what you're interested in. Which ones are most likely to fail if you broke something? So you can train a machine learning algorithm on your CI to figure out like which are the tests I need to run when I change these bits of code. Our video person did this animation lately, so I really want to show it to you. So the idea is, you take the code, you take the test data, and the history of having run all the tests like ever, or since you enabled it, and the model will figure out which are the tests you need to run. So these are the tests you really need to run, and then predictive test selection will only run the tests that you need to run. And it will use those results to update the model and figure out like what you need to do. The idea of predictive test selection is not necessarily to use it on all of your code branches, because presumably, when you release, you're going to want to run all your tests yes or yes. Like, even if they're tests which always go green and are completely pointless, you still want that nice feeling of, I ran all my tests. But certainly for local builds, and certainly for a bunch of other types of branch builds, you're not always going to want to run all your tests. And what we've found, I don't have it in this presentation, is that what the meta paper said was that they generally run, I think it was about 30% of their tests. But it varies. It depends on the confidence of the results. So 30 to 60% of your tests. So you could be saving like, 70 to 40% of your time on your test run. Now, when you use all of these things together, you get this kind of force multiplier effect. So you use the build cache to not run builds and tests when you don't need to run builds and tests. You use predictive test selection to narrow down the number of tests that you need to run. You use test distribution to run them over multiple agents and massively parallelize them. And this thing, performance continuity, is using metrics and data to keep an eye on your performance and make sure that you don't introduce new regressions or make sure that changes that you've made don't make all of this stop working in some way. So I've been asked this question before. Is the build and test cycle fast enough? And the answer to that question is, well, it's fine, right? What can you do? But it's not really the right question. The question we should be asking ourselves is the build and test cycle as fast as it can possibly be? Obviously, the answer is no, and obviously the answer is always going to be no, because there's always going to be improvements that you can make. But I think this is the goal we should be setting ourselves. What's the next set of improvements we can be making to our build and test cycle? Like any performance problem, let's take the quick wins and the things which are slowing us down and address them one at a time. Dependency downloading takes 20% of the build time. OK, let's fix that first. Now, what's the next thing to look at? And just continually work on this and continually monitor it until we're getting that rapid feedback loop that we want to kind of improve our quality and productivity. OK, next pain point, inefficient troubleshooting of broken builds. It's very difficult to figure out what on earth is going on if you're not looking at what is going on. This is particularly troublesome for local builds, and particularly now more of us are working remotely. Like if our local build breaks, and we ask our build guru, dear build guru, something broke and I don't know why. And they go, what broke? And you're like, I don't know. And you show them a stack trace, and they say, what version of Java were you using? And you tell them. And you say, what operating system? And you tell them. And what were the flags? And you go backwards and forwards to figure so that this person can help you figure out what went wrong with your build. If any of you were in my talk this time at lunchtime, then you already heard this story, because it was the same thing I talked about build scans. So build scans are a way to get visibility over exactly what went on in your build and allow you to share that with other people. So you can kind of show them, this is the build, this is why it's broken, these are the dependencies that we used, this is the infrastructure that it ran on. Whether it's a local machine or CI, then you can kind of share all of that information. Build scans from scans.gradle.com are free. But I recognize there are going to be some constraints for people who do not want to send their build data off to some random server. But they are free. You can try them out with like an open source project or something like that if you want to. Now, if you're a DPE organization, a 10x organization, you're going to be using this kind of data to track what's going on in your organization. So now, you're not only looking at, presumably you have some sort of metrics on what's happening in CI. But presumably, you don't really have metrics on number of failures on the local machines, or what's causing the failures on local machines, or how many users are impacted by a specific failure. If you start tracking this sort of information, you can start finding what is really slowing down our developers. What kinds of problems are the problems that affect all of our developers versus just one developer shouting very loudly about their specific problem? Without the data, you can't answer any of those questions. And build scans is one way to do that, but at least some way of figuring out what's happening on the local developers' machines is a step forward to figuring out what is slowing developers down. Next pain point, flaky tests and other avoidable failures. I hate flaky tests. I'm almost famous for hating flaky tests. I hate flaky tests so much that when I worked at LMAX, they invented a tool called AutoTrish to find flaky tests for me. Because otherwise, I wouldn't do any code. I'd just spend all the time trying to figure out which of the tests are actually failing and which ones are flaky. So when you come across a test which fails, what do? You rerun it, just in case. And you rerun it a few times just to see if it really passes or not. And if it passes, then it's a flaky test, and that's OK. I'm just going to approve the PR anyway. You're like, wait a minute, didn't that test fail? Yeah, but sometimes it passes. Okay. So I absolutely hate flaky tests because I feel like they're clearly a sign that there's something wrong. But they're so difficult to identify and fix that they're like a toxic drain on the team's morale. So there was a survey done, and it said, our analysis revealed that rerunning the failing build and attempting to repair the flaky test were the most common activities. I'm kind of surprised that people actually attempted to repair the flaky test, and well done them. Maybe they were just lying on the survey results. But rerunning the build is definitely the most common thing to do when you have a flaky build or test. What was more interesting is they found that developers who experience flaky tests more often are more likely to take no action in response to them. As soon as you have any flaky tests in your build, you start ignoring the flaky tests. And then you start ignoring the other tests that are failing. And then you start ignoring a lot of stuff, because you're like, well, it's just, I don't really know if it's failing or not, and I don't really know how to fix it. And this is why I hate flaky tests. They're toxic. They just make everything seem really pointless. So you need to identify your flaky tests. This is Develocity's dashboard. The idea is this old screenshot uses reruns. So if you configure your build to rerun failed tests, if it fails the first time but passes the second time, then you know it's a flaky test, and then you can mark it as flaky. There are other ways to do it. So that you can actually look at tests across builds and see the pattern of how frequently it passes and fails, given the same inputs. So you really want to be looking at these tests which fail and pass and fail. So this is the spring information. The last time I looked at the spring one, the top failing one was an integration test, which is not really surprising. These integration tests are quite often, there's a lot of things to wait for, and they're quite often flaky. Dave Farley did a really good video on the Continuous Delivery channel about the 5 causes of test intermittency. So step 1, find your flaky tests. Step 2, fix them, please. Don't just go, oh, good, it's a flaky test. I can ignore that. So this is really good, and it talks about how it could be the tests, it could be the production code, it could be the infrastructure, it could be a bunch of stuff. But the point is, it is a problem, and it needs to be addressed. And then I hate flaky tests so much, I wrote like 3 blog posts about this. At the end of the slides, there will be a slide with a QR code which has all the links and stuff on it. Next pain point. No metric/KPI observability. No data, basically. You have no idea what's going on. Let's say you actually spent time optimizing your build and looking for pain points and identifying flaky tests. And then you go, right, we're done, right? We fixed it all. Everything's great. But, I mean, you know how code works. Over time, even if you don't make changes, things just get worse. I've got a load of pet projects and demo projects I use for these kinds of demos, and there's no one else working on them. It's just me. But I'll come back to them a year later, and it doesn't work. And the combinations of dependencies changing and Docker changes and the database changes and stuff, even if you try and keep things stable, stuff changes from underneath you. And that's without you making any changes. Now, if you're working as a team and you're committing lots of changes and you're changing the database schema and things like that, generally speaking, performance will decrease. So you need to keep an eye on all those wonderful changes that you made to decrease your feedback cycle times. You want to keep an eye on them so that you can make sure they don't get worse again. Because entropy states that things are just going to get worse if you don't do something about it. And then Mike Nygaard said this in Release It's 2nd edition. I love this. It says, the tools, services, and environments that developers need to do their jobs should be treated with production-level SLAs. The development platform is the production environment for the job of creating software. And I think we don't think about it this way. I think we think about production and my laptop. But my laptop is the production environment for producing production-ready code. So we need to be monitoring this. I hate the idea of monitoring, because I'm not talking about monitoring developers and seeing if you're like typing as much as possible, but like figuring out what is wrong with this environment, what could be optimized, what can speed us up, what can help us. And we don't do that. We just go, this environment's a bit crappy, and my QA environment's a bit flaky, and my staging environment never really quite works. And all of those things are on the path to production and should be treated with production-ready SLAs. Last pain point, inefficient use of CI resources. Now, the temptation, certainly for me, is to think, Let's assume that we've optimized everything. We've got a 20-minute build time down to 5 minutes. We've got build caches, so we're not running a bunch of builds. We're using PTS, so we don't run half of our tests. It might be that this brings down our cloud costs. It's entirely possible. What we quite often find is that it doesn't necessarily bring the costs down, but it brings queuing times down. It brings, we're using the CI resources more efficiently. We do more builds in a smaller amount of time. So it may or may not save money, but it will certainly be a more efficient use of your CI resources. So, oh my goodness, I'm actually going to have time for questions. I am shocked. In summary, I'm not sure if 10x developers exist, but 10x organizations definitely do exist. Like, they are demonstrably, I like that word, they demonstrably exist. So there is evidence to show that 10x organizations are real. There are things that organizations can do to make all of their developers more effective. And I think that's much more cost-effective than trying to identify a single 10x engineer. Developer productivity is deeply linked to developer experience. Our productivity is deeply linked to how much fun, or at least not terrible, it is to code. So if there's slow builds, if there's tests that don't work properly, if there's an environment which just like needs a magic incantation and works only on Friday afternoons if you feed it enough goat's blood, like that's not fun. That's frustrating. So the developer experience is an important part of our productivity. If you don't do anything about productivity, it will get worse. It just will. That's entropy. That's what happens. Fast feedback, efficient troubleshooting, and reliable cycles are key. So obviously, our sales guys would love to hear from you and have you say, let's buy Develocity. That's clearly the answer. But it's not about buying a single product. It's about thinking about these things. Fast feedback, efficient troubleshooting, and reliable cycles. The reliability, I feel like, especially in our local environment, is not thought about often enough. Now, I've given you loads of different ways to address these different pain points, but really the takeaway point is start with observation and take action on data. So measure your local build and test times. If your cycle time is like 30 seconds already, then you're probably fine. You don't need build caches and PTS and all the rest of it. Maybe it's something else which is slowing you down. But you want to start measuring stuff, observing things, looking for patterns, looking for where the toil and the friction exists for the developer experience. And then proactively solve problems for the whole team. And this is why I love DPE and developer productivity, because if you can address one of these problems, like build times, you address it for everyone. I'm not just fixing like your problem and the rest of you, well, sorry guys, I'll get to you at some point. I'm addressing a problem which impacts all of you, and I can help level you all up. And this is how we get 10x teams, because we can do it all together. The main point I love about DPE is that our users, so this is a slightly biased user group, but our users say that 84% of them say DPE's impact on their toolchain makes their job more enjoyable. So obviously, when we're talking to the C-level members of our organization, we talk about productivity. But when we're talking amongst ourselves to other developers, we're talking about developer joy, and we're talking about like actually removing friction and removing all the rubbish that gets in the way of our day jobs. But if you do want to talk to the C-level to try and sell them on developer productivity, if we look at the problems we have down here at the developer level, slow builds and feedback cycles, inefficient troubleshooting, testing, and CI, if we can fix slow builds and feedback cycles, we get faster delivery, which means increased revenue. We get more resource efficiency, improved productivity, decreased cost. If we can fix inefficient troubleshooting, testing, and CI, again, better efficiency, improved productivity, decreased cost, and better quality and a better brand image all around. So these seemingly small things, like our build times, our test times, have a very measurable impact on the things that the C-level folks in your organization really do care about. So what's next? If you want to have a look at the slides and the resources and stuff from this talk, then that's this QR code. If you want to win a copy of my book, then that's this QR code. Please feel free to take a copy of both of those QR codes. And I have time for questions. So thank you very much.